Hi folks, Sean McGraw, American Veteran Air Condition. If you haven't subscribed to us, please subscribe to our channel, and that way you can follow through. We can know if we're hitting the right stuff. If you have some stuff that you'd like us to touch on to kind of clarify some things for you, please let us know. If we miss something, respectfully, please let us know as well. We don't want to give out false or inaccurate information out there. Simplest thing to do, there's two ways you could check this. When it's on a Molex plug, it's hard to check it coming off the wire, or actually literally impossible, because you would have to unplug this whole Molex plug in order to check it. So on this particular furnace, we can't check it from the wire to the control board. We got to check it from the flame sensor to the wire, which is going to the control board. Hopefully I didn't lose anybody on that. On some furnaces, you will have an independent wire that's not hooked up to a Molex plug that you can literally take off a spade connector and hook from there to the control board. This particular one, we can't. So in order to check this, what I would have to do would be to pull, and I've already got this all disconnected. Generally, this would be screwed down where it's supposed to be on your flame sensor. What we would end up doing is we would put our meter on microamps. You need a good meter that reads microamps, all right? So after we do that, we'd start running the furnace. While we're doing that, we're running our meter in series with the flame sensor. Now, like I said earlier, this wire is putting out 130 volts, or 130 volts. It's putting out voltage AC. Whether it's 40 volts, whether it's 103 volts, it's putting out voltage AC. So you want to make sure that your hands aren't tied in there. Usually you would probably want to use some alligator clips or something like that to where your hands could just be hands-free on there. In this case, I don't have that. So at that point, we would check in series between the flame sensor and the control board while the furnace is running. So once that flame lights up, we should, if the flame sensor is good, be reading between 0.5 and 10 volts AC. Or AC, 0.5 and 10 microamps is what we should be reading, between 0.5 and 10 microamps. Usually between about 3 and 5 is what you'll see on a good flame sensor. If we're getting that, you know that this flame sensor is good. All right, if you're not getting that, what could be the problem? If you're not getting that, you can pull the flame sensor out, and if it's corroded up real bad around the I'm not meaning to flip y'all off. Okay, how about that? If it's corroded up real bad around the flame sensor, best thing I found to use on that, let's see if I got one in my pocket. I do, is a dollar bill. I found a dollar bill to be the least abrasive thing to use to clean those. So I'll just grab it by the porcelain there and clean it with a dollar bill. So why do I use a dollar bill? All right, now we mentioned before these aren't thermocouples, they aren't thermopiles. They don't operate on the same thing. And I might have misspoke on an earlier video. I'll have to double check myself and make sure I didn't. But what these are doing is it has a piece of metal in here which is rectifying the voltage of DC. And it is actually sending that through the flame to the burner box, and the microamps is picked up by the furnace control board. All right, so if this is dirty, it's not able to rectify that voltage. And what happens if you clean it with something extremely abrasive is you create grooves in there, to where at the same time, this is a conductor. And if it's real dirty, it's got grooves in there, it's able to create carbon and soot and everything else, then it immediately starts to fail again. So we want that smooth, we want it nice to where it's not able to collect a bunch of debris and carbon, where it would essentially insulate this flame probe and allow it not to conduct that current back to the burner box again. That's why I like to use a dollar bill. All right, the other thing to check while we're on there is to make sure that we look around in here and make sure that this isn't shorted in any way. By shorted, I mean this is a conductor and it's insulated by this porcelain right here. If this porcelain is cracked, then at that point, that AC voltage, instead of being rectified by the flame sensor, could essentially just be grounding straight to the box. Usually you would end up having more problems than just a flame that's not igniting at that point. You would probably see trip breakers, things of that nature. But that's one of the other failures that could be on here. The other failure could just be open. So if it's open, then you're not getting anything across there. But if it was open, you wouldn't be getting the current coming back through. All right, so there we go. We're checking for microamps, 0.5 to 10 microamps coming through this flame rectifier right here. Other things to check is a solid ground. So the furnace control board is grounded to the casing of the unit. A good ground, we'll discuss that a little bit further here in just a minute. In order to check the ground on there, we just want to go ahead and move our meter to ohms. We'll go to our neutral bus down here. We want to make sure that we got good continuity. Should be between 1 and 3 ohms or so. So we got about 1.8 right there. So we got a good ground going back to the burner box. The other thing we want to check on there is make sure that our polarity is proper going to the furnace control board. I've seen that being a problem before in the future as well. One thing I have found useful is if we don't have a real good solid ground coming back, I've actually pulled a new ground from the control box and ran it straight back up through here and tied the ground directly to the burner box. Another thing that I've found in the past as well is that an intermittent failure, meaning it worked fine when you were there and then you leave and magically the gremlins go back in the unit and it breaks down again on them at 2 o'clock in the morning. A lot of times that's due to just that ground being loose, to where just a quarter turn on a nut driver could tighten up that ground and solve the whole problem and solve you a lot of headache and the homeowner a lot of headache. All right, I'm thinking we just about covered everything. We cleaned the sensor, we did everything we needed to do. So making sure that's tied back in. So if everything else failed and you're trying to figure out what's going on, your flame sensor's good, it's putting out the microamps that you need to and all that, your polarity's right, you got no shorts. How do you check to see if it's actually the furnace control? That's the problem. Well, if you're lucky, you can go ahead and move your meter to volts AC. And you can check this directly to ground while it's running. And while it's running, you should be reading between 40 and 90 volts AC, somewhere in that. Might be a little higher. Now, like I said, unless it tells you on the furnace control, which some of them do, as to what the output voltage is on the flame sensor, it's really hard to tell if that's the problem or not. But if you checked all of that stuff, then you're generally going to be pretty good. Hey, look, if y'all are looking for more tips, we're always looking for your feedback and we want to answer your questions, and we will on a regular basis on our YouTube channel. So subscribe right here to our YouTube channel, not here to our YouTube channel. And we'll try to make sure we take care of all the questions and answer them efficiently for you. Y'all take care. God bless.